right, we are back with Mr. Jeffrey's Algebra 2 with statistics. Yeah, that's right. We have about 83 subscribers now, so we just need, 917 more before I get the mohawk and dye it and put it on the YouTube. We are actually redoing a lesson I totally messed up last semester. Okay, so I've got it fixed now. It's not as confusing and things like that. So our rational functions, we still have our A, our H, and our K. What's weird about rationals is that they still do a little bit of the stretch and shift and all this kind of stuff, but we really aren't worried that much about it. Okay, so we have so x equals h is the vertical asymptote. Okay, and I'll explain that here in a second. Y equals k is a horizontal domain, all numbers except h, range. Okay, so it's actually a lot easier than what it looks like. So our h value, remember, it's the opposite of this. So this is -2. So our vertical asymptote is x equals -2. And our domain is x not equal to -2. Okay, and I'll try to graph this here shortly or give you an idea of what's going on. All right, so k, -1. We have a horizontal asymptote at y equals -1. And our range is y not equal to -1. Now, um, there is another way to write this, and I could, so this would be domain is x uh, such that x is element of real numbers not equal to -2. All right, this is like one of the mathematical ways where they make their own letters and stuff. Yeah, I'm not going to make y'all do that. Um, the only people that need to do that are like theoretical mathematicians, and nobody really wants to theoretically do math. Some of y'all don't even want to do regular math, so that's okay. All right, so now an asymptote. An asymptote is this weird phenomenon in math, which it makes sense. It's math is all types of weird stuff. All right, we had a horizontal or a vertical asymptote at x equals -2. Basically, we have this line right here at -2 that we get really close to, but we never touch. Okay, it's kind of like those invisible fence things that you see for dogs, where they get really close to the fence, but the only, like, now if they're like my dog, they like get a running start, so it only shocks them for a little bit, and then they're already gone through the fence, and it doesn't hurt them. But so we have that, and then we have a horizontal asymptote at -1. Okay. Now, the reason why, and I'm trying to remember what this will look like. Basically, this graph gets really close to these two things, but it never touches it. Okay. Uh, these are such crazy things. I don't even like making people graph them on paper. I don't even remember how to graph them on paper. I'd have to Google it or something. Another way to think of those asymptote things, I don't know if y'all have done this with your siblings or with your friends, is where y'all do that thing where you get your finger, you get really close to them, and says, I'm not touching you, I'm not touching you, I'm not touching you. That's basically an asymptote. Okay. I found out last night my wife really doesn't like that game. She gets kind of annoyed and throws things at me. All right. So That's basically what we're doing right now with rational functions. So, and it's almost like the person who has made your notes try to put everything together to make your life easier. I wonder who would do such a thing like that. Hmm. All right. So, our h value right here, we don't have anything plus or minus, so our h has to be 0. That means our vertical asymptote is x equal to 0, and our domain is x not equal to 0. So value, x equals to it, x not equal to it. That's all we need to know. All right. Our k, -2, we have a horizontal asymptote y equals -2, and our range with y not equal to -2. Ta-da! Isn't this fun, everybody? Aren't y'all having a great day on this Monday? What about next Monday when we don't have school? That's a good Monday. What they're trying to do, I have students about 30 feet away that they're trying to make noise to be caught on the sound with the microphone. And it's somewhat of like a dying goat singing contest going on right now. So I'm just glad that this microphone only picks up just a little bit. And yeah, this is awesome. This is why you definitely want to be a teacher. Okay, so moving on to number 2. Our h value is opposite of this. So what's the opposite of +4? Bam. So our vertical asymptote is x equals -4. Our domain is x not equal to, wow. Just had another student complain that another student is breathing. Now they actually happen to be trying to breathe on them, but I'll just take it as breathing. Okay, our k value. What is our k value? What is the value over here? 0. So we have a horizontal asymptote at y equals 0 and a range at y not equal to 0. Ta-da! All right. So, pretty simplistic. All right. Number 3. What's our h value for number 3 right here? 1. That means we have a vertical asymptote at x equals 1. We have a domain of x not equal to 1. We have a k of horizontal asymptote at y equals 5 and a range at y not equal to 5. Now, it could be worse. There are some Algebra 2 classes in this school building where people are having to do this and explain it more and do the graph and wonder why their graphs look so weird. All right. Are we good through right here? Yes, no, maybe so. Catch a tiger by the toe. Bubblegum in a dish. All right. So, from here, We're going to move on to the next part. All right. So we're rewriting these. Now, this is about as far as long division as we're going to ever do in my classes. Okay. So we would basically write this part right here, this part, as a long division thing. Okay. Well, how many times would we need to multiply? Well, we would need a 3 right here. It's got to be the same as that. And we subtract it. This is actually subtraction right here. That's not 5 plus 3 equals 2 to confuse y'all. All right. Here's the crazy part. What we get right here is now written right here as our A. What we get right here, this is actually our K. And this kind of stays the same, which is good because that's our H values, and those are the ones that are kind of kooky. All right. So, ooh, all right. We're going to say x plus 1 is going to go into 5x plus 6. All right. So, what are we going to have to multiply by x to make it be 5x? Bam. Okay. So we're going to have 5x plus 6. Now, we are subtracting right here, so this would actually change to this. Oh, that's not 5 times 1 is not 6, it's 5. Yeah, it's a Monday. Struggle. I feel like I've been hit by the struggle bus and I'm being dragged down the street. All right. So these cancel. I'm left. What is 6 minus 5? All right. So when we write this now, this will be 5 over x plus, wait, nope, sorry, not 5, sorry. 1 over x plus 1 plus 5. That's it. And I really should have changed those colors better. This should actually be blue. This should be red. That should be blue. All right. And that's it. Yay. All right. With number 5, first thing we do is rewrite this. X plus 3 goes into 7x plus 4. All right. What are we going to have to multiply x by to make it be 7x? What are we going to have to multiply x by to make it be 7x? 7. So we're going to multiply all this by 7. So we get a 7x here, and we get a 21 right here. Now, due to the fact that this is subtraction, because you remember we'd multiply then subtract with long division. Okay, these go to 0. 4 minus 21 is actually negative 17. All right. Our minus 17 goes here, and our 7 goes here. Ooh, what is that? And our g of x is now this. All right. So, in a nutshell, that's the lesson. Okay. For those in class in our in studio audience, they actually have a little bit more to do. For everybody else, this is where we leave you. Okay. Don't forget, hit the subscribe, hit the like, hit the bell. And as always, good stuff, good things.